You know the saying, right? All that glitters is not gold. It's a classic piece of human wisdom, basically telling us that appearances can be deceiving. But what happens when you try to explain that to a machine, to an AI? Well, it's not about poetry or feeling then. It's about pure, cold logic. And today, we're going to do exactly that. Translate this proverb into the language of machines.
So really, how does a computer get it? I mean, it can't understand the cultural history behind the phrase. It just sees words. What it needs is a precise, totally unambiguous formula. It needs to turn our kind of messy human language into the super rigid structure of predicate logic. And that's what we're going to build, right now, step by step.
Okay, so before we can even touch the is-not part of the proverb, we have to solve a simpler puzzle first. Let's just park the word not for a second and focus on this statement, all that glitters is gold. Trust me, if we can nail this part, the rest is going to fall right into place.
To build this logical sentence, we need a few key ingredients. First, we need a universe of things we're talking about. We'll just call any given thing X, which could be all metals or all objects, whatever. Next, a quantifier. Since we're saying all things, we use the for all symbol, which looks like an upside-down A. And finally, we need predicates, which are just statements about X. So we'll have glitter X, which means X glitters, and gold X, which means X is gold. Simple enough.
Okay, so we've got our pieces on the board. We know we're talking about for all X, and we've got our two conditions. It glitters and it's gold. The real puzzle now is how do we connect them? What's the logical glue that holds these two ideas together? And this right here is where things get really, really interesting.
And this brings us to a huge decision point, a real fork in the road. There are two logical connectives that seem like they could work, but picking the wrong one is, and I'm not kidding, probably the single most common mistake people make when they're learning this stuff. This choice is everything. It's the difference between a statement that's logical and one that's just plain wrong.
All right, here are our two contenders. Over on the left, we have option 1, which uses that arrow. That symbol means implication, so you'd read it as, for all X, if X glitters, then X is gold. Now on the right, option 2 uses that little wedge symbol, which is a conjunction. That's just a fancy word for and. So it reads, for all X, X glitters and X is gold. They sound kind of similar, but in the world of logic, they are worlds apart. So, which one is it?
So, spoiler alert, the correct answer is implication, that if-then statement. And to prove it, we're going to use this really simple but kind of brilliant test that I like to call the rose gold test. This one little real-world example is going to show you exactly why one of these formulas works perfectly and the other one just completely breaks.
Now the secret is all right here, in the truth table for implication. Don't let it intimidate you. Just focus on that third row. It says that if the A part is false, so something does not glitter, but the B part is true, it is gold. The whole statement is still considered true. Now that might feel a little weird, but this is the absolute key. It allows for the possibility of things being gold without having to glitter.
And boom, this is where it all clicks. Think about rose gold. It doesn't really have that bright, glittery shine of yellow gold, does it? But it is 100% still gold. Our implication formula handles this perfectly. That third row of the truth table says a non-glittering thing that is gold doesn't break our rule. The logic holds up. Okay, so now let's look at the other option, conjunction, the and statement, and see how it completely falls apart when we give it the exact same rose gold test.
See, the and statement is just way too strict. By claiming that for all X, X glitters and X is gold, it's making this wild, absurd claim that everything in the universe, every rock, every planet, you, me, both glitters and is gold. The second you find one single thing that doesn't fit, like our friend rose gold, the whole statement becomes false. It leaves zero room for nuance. So yeah, implication is our winner, hands down.
All right, mission accomplished. Now that we have our solid, correct formula for all that glitters is gold, we can finally circle back to the original proverb. It's time to bring the not back into the equation and solve this thing once and for all.
So how do we say all that glitters is not gold? Well, the starting point is actually super simple. We just take our entire correct formula from before and we stick a negation symbol, that little nega hook, right out front. This literally means it is not the case that for all things, if they glitter, then they are gold. But we can definitely make this look a lot cleaner.
And now for a little bit of logical magic. We're going to push that negation symbol inward, step by step. First, the not flips the for all quantifier into a there exists quantifier. That's step 1.
Step 2, we expand that arrow, the implication, into its equivalent form, not glitter or gold. Step 3, we apply the negation to that, which flips it to glitter and not gold. And that leaves us with our final, much simpler result.
So what does this final formula actually mean? Let's translate it back into plain English. It says, there exists at least one thing, X, such that X glitters and X is not gold. I mean, come on, that's it. That is exactly what the original proverb means, that some shiny things out there are just fakes.
And to really hammer it home, just think of a piece of aluminum foil. Does it glitter? Yep. Is it gold? Absolutely not. Aluminum is the perfect example of an X that makes our formula true. It exists, it glitters, and it's not gold. The logic works perfectly.
So, we just walked through a pretty specific example, but this whole process actually uncovered a really powerful general rule. This is the big takeaway that's going to help you solve a ton of other problems in logic.
Here it is, your rule of thumb. When you're translating a statement about all or everything, the for all symbol, that for, is almost always going to be paired with implication, the arrow. And when you're talking about something, or that there exists something, the exist symbol, the E, is almost always going to be paired with conjunction, the and symbol. If you can just remember that, you'll avoid that super common mistake we talked about earlier.
And there you have it. We took a piece of timeless human wisdom and broke it all the way down into a precise formula a machine can understand. It really makes you wonder, as AI gets more and more advanced, what other simple human rules of thumb about life or trust are we going to have to teach them? What's the next proverb we need to translate for them? Thanks for sticking with me.